plant? How much is drained out? How much is evaporated from the surface? Why does that, why might that matter? Why would you care if you're doing environmental assessments about sort of the water balance?
Well, like in eastern Colorado, they're doing a lot because there's like a certain water table that's there, and the rate at which the farmers are using that water, it's going to be basically gone in like 50 years or something.
The Ogallala Aquifer, which is quite a big part of the kind of eastern Great Plains, or well, northeast Colorado, parts of Nebraska, Kansas are kind of the main parts of that. Yeah, there's a lot of groundwater. And so, yeah, so the whole issue of, if you're using groundwater, that's a limited resource. And you might want to know in evaluating environmental sustainability of biofuels, is that dependent on that limited resource? But the other part of it, too, is just saying, it's kind of like anything. It's like the land resource. If you're using water for biofuels, that maybe has implications on water availability for other things. So, again, it's a metric that there's not an exact way to, to rate it, but it's an important, water is an important resource in short supply, and so therefore we want to know something about the water use of these systems. Yeah, sort of a figure about what the plant looks like. Okay, here's what the main thing today is really, the objective is kind of get you guys familiar enough and comfortable with understanding kind of the input-output structure of this model so that you can use it. So I'm going to spend a little bit of time talking about this. And this, again, this is for the Century model, and it's a little bit different for the Descent model. Namely, there are a few additional input files, but the main ones that you guys are going to have to be concerned with largely here are the same as you see here. Okay, so let me spend a little bit of time explaining how this works. Okay, so here's like the simulation model. Okay, all the equations and stuff are there. You, in terms of a user, you need to sort of tell the model for your particular application kind of three types of things, okay? You need to say first kind of where you are, okay? And so where you are is going to affect things like the soil characteristics, all right? So that's going to be something that's going to vary within your feedstock production area. And the place in which you define things like I mentioned before, the soil texture and some other things like this, there's a file here that's called site.100. And so think of site as the location you're looking at. Now in your feedstock area, you can have lots of locations, okay? Because you're going to be looking at kind of a mosaic of different patches of land that have where, let's look at it this way, because this might be useful to give you a little bit of an idea of how this is going to work or what the concept is. Okay, so you've got a feedstock area. Or put it this way, you've got a place where you're going to put a biorefinery, okay? And I think I gave you guys the names of towns or something like that. And you can imagine you've got, some potential feedstock area, and for kind of to look at the issue of transport and distance, you're going to get some map overlays, and you're going to get land areas that are stratified. One of the stratification variables is going to be distance, okay? And for simplicity, we're kind of doing this as, as annuluses here, okay? And I think what you're getting is, you're going to get 25 kilometers, 50, 75, and 100. Okay, so you're going to get that. So distance. So for every one of these distance annuluses, so imagine this as a series of maps, and you overlay them, and then as a result of that overlay, you're going to get a set of polygons which are unique in terms of their characteristics, in terms of their strata. So strata here is going to be, we'll call it distance. Land cover, this is going to be very grossly defined as, as annual cropland, grassland, forest, and then kind of an urban and water, but those are sort of throwaways. You're not going to be doing really anything with those. So that's kind of the land surface, okay? You're going to get another strata, which is going to be, we'll call it soil type, but it's really just going to be soil texture, okay? If you really wanted to do this thoroughly, you'd use other characteristics, but we're just going to do that. We're also going to give, and we'll see, this may be a little too much. I have to do one of the overlays and first see, but tentatively you're going to get also slope. So slope class. In other words, that would be areas that are like more or less flat, or kind of gently sloping, or steeply sloping. Well, no, we're not going to necessarily include that in descent, but it could be something that you might want to use as a criteria for your, so we probably won't be using it in descent. You could, if you wanted to introduce erosion, soil erosion, but you'd have to use another model to kind of get the erosion values. But so we're not going to go, you guys have enough to do. But you're going to get a map nonetheless with this slope class. And so, yeah, these three here will really be what you're also going to get a map, or a map is going to be included of sort of the road and rail network. And we'll talk more about how you're going to use that later. But so it's these three here that are going to determine the strata. So basically what you can imagine, and let's just make this real simple. So let's say here's your distance, and then you've got, I'm going to get another tab on this thing. We should really go back to chalk, I think. It doesn't feel the old enough from the chalk desk. It's still better, at least it works. Okay, so let's say we got forest over here. And I'll just, and let's just say that's all it is. And this is grassland, okay? And then, let's see, get another color. There's another one back here. Black, okay, maybe the black works. And then let's say you're going to have some soil types. Let's just make this simple again. And let's just say this is a sandy soil, and this is a loam soil, and this is a clay. Now it's going to be a lot more, they're not going to be big contiguous areas, but what you'll do is you'll get summaries by annulus, land class, and soil type. So that means that you would have essentially a set of polygons. So this, for example, would become one land unit, and it has attributes of a sandy soil presently on forest, and in this 25 to 50 kilometer annulus. Okay, that defines, for your purposes, kind of a homogeneous land area. Okay, so Century doesn't care how far you are from the site, but it does care what the soil texture is and what the initial vegetation is, okay? So those will be attributes related to that will be, a site file. Essentially what you'll have to do is you'll have to have a unique site file for every unique polygon in this intersection of these three different strata. Does that make sense?
Yeah, but so that site file is input as a unit area. It doesn't matter.
You're going to get an Excel spreadsheet, and so you'll have the attributes that you need to put in here, and then you'll have an area associated with that. So the area just becomes sort of a multiplier, okay? So you don't have to worry about the area, but for right now, because again, think of it as running the model for each unique hectare and what makes a hectare unique in this definition is this stratification by land cover, soil type, and distance. And actually distance is something that you're not gonna, so it's really gonna be, well, the other thing I didn't bring in was climate. So you're also gonna have climate, but we may decide to just do this as a single climate area.
How much is the climate? Climate in terms of what?
In terms of temperature and precip.
Like, would that change over a 50?
It'll change a little bit, but it won't change, maybe all that much. So I think we're
Yeah.
probably gonna simulate it, simplify it. And I think last year we just got one climate file. Looks troubled. Nope, okay.
And is that map something that we do, like?
You're gonna have all that hand delivered to you, so, and it'll just, in most of it'll be the post-processing, but really it'll just be the soil types and, and something about the previous land use that'll have to be defined. Okay, so back to this. So here's an input file that's gonna be unique for the particular land area you're looking at, okay? Weather, as you can imagine, has the weather data. And yeah, I was thinking about whether or not we'd have 2 or 3 different climatologies there, but I think it's easy enough to just treat that as uniform. So you'll get a weather file and you won't have to do anything with it. The main thing that you're going to have to work with, there's not going to be a huge time sink that goes into kind of setting these site-specific characteristics, is defining the land use and management, okay? And that's what we call event files, or an older name was kind of schedule files. And these are files that you're going to build with a text editor. And I would say that to get this thing running, that'll be, a lot of your effort will just be learning how to put, the land use and management into that format for the model to use. Okay. Any questions so far? So I think I've gotten a few. Oh, the other thing is, so all these files down here, you can probably figure out kind of what they are: crop, cold, fert, fire, graze, hard, irrigation. These are parameter files, okay, that define all the different kinds of management activities that can go on. And within these are a number of what we call events that are, pre-specified there. But you may also want to create your own sort of unique event, okay? And if you do that, you'll have to create a little parameter block in one of these .100 files. And some things you probably won't mess with. For example, cultivation. There's lots of different tillage types, and all you need to know is the name of the tillage type, and that's what goes up into the schedule file. When you say, okay, it's, I want to till in month or on day X in this cropping sequence, I want to use this type of tillage. There's basically a code that corresponds to that. And there are parameters then that essentially make the model do different things that are affected by that type of tillage. Well, one example might be, for example, in fertilizer .100, that's basically you specify, the amount of fertilizer and, it's something about the type. And, if you decided that, I want to put on 129 kilograms per hectare, and that wasn't there, then you create that fertilizer